Hello everyone. So today, before solving this question, I'll try to upload a different video today only for this question inversion of array. And you will notice that here it is written prerequisite is merge sort. And a merge sort is a very famous interview question as well. It can be asked in various interviews as well, like what is the time complexity, and since it's a recursion question, so to understand that recursion as well, I have created this separate video for merge sort. And since I mean, obviously, you need to know how merge sort works. Other other sorting techniques like bubble sort, insertion sort, quick selection sort, these are O of n square solutions, and they are not as much asked in interviews. But questions like merge sort and quick sort, they are definitely asked in interviews. So let's go forward with merge sort. What exactly is merge sort? And what we'll understand is first I'll explain you. Then I'll try to write a pseudo code, right? And then we can we can go forward with dry run, but I think I won't be able to my I don't have any stencil, to write on the Excalidraw. So it would be much difficult for me to, explain either dry run, by for every recursion. But yeah, I'll try to, and then we can probably code it, right? This is the question that I've found, sort an array, and you will notice that here it is written O of n log n in time complexity that we have to solve. So without further ado, let's start with this question. Okay, so let's take any further example. Great. Let's take this very basic example and write it here, right? Or maybe what I can do is I can add various elements in it. So 6, 3, 8, 2, right? Not 2, maybe something different. Yeah. So that I can, at least um, I can at least show you like how you can solve all these questions. Great. So let's see what is the length of this array code, right? So it's 0, 1, 2, 3, 4, 5, 6, 7. So it's 8, right? The length of it is 8. 2, 4, 6, 8. Yeah. The length of it is 8. Or maybe let's do one thing. Let's probably add one more element to it so that I can first show you how um, you know an odd length array can be sorted. So let's erase this n. Let's write it 9, right? You, b- I won't tell you anything right now. Just look at what I'm trying to do. All right. So what merge sort is? Merge sort is basically divide and conquer, right? Or merge, right? In an optimistic way, you can write divide and merge, but it really is divide and conquer. Now, what does divide and conquer mean, right? It, as the word suggests, that you have to first divide it and then you have to merge, right? How can you divide it? Okay. The length is n by n, and that is 9. It's an odd length, right? So if you divide it by 2, right? If you divide it by 2, you will get either the floor you will get as 4 or you will get 5 as the seal, right? Because 4.5 is what you will get and the floor is 4 and the seal is 5. Great. Let's try to divide it by 5 and 4, right? 5 and 4. So I'll write 5, 2, 3, 1, 6, right? I hope these are great. And here I will write 3, 8, 7, 9. I've divided it into two parts. Great. I will divide it even further, right? I will divide it even further. Now again, this is length 5 and this is length 4. As you know in recursion, generally left part is first done and then you come on to the right part. So we'll touch this later on. Let's try to solve this. Again, length n is equals to 5. So dividing by 2, it will give you 3 as the seal. and 2 as the floor. So we'll again take it like we did here. So we'll take three elements here, 5, 2, 3, and simply 1 and 1 comma 6. Great. Again, this is 3, again divided into 2. Again, we'll take, we'll simply say that, hey, divided into 2 comma 1 part, 2 ratio 1 part. So 5 comma 2, and here it will be simply 3. Great. Is is it sorted? No. Again, do one thing. Just divide it by 5 into 2 parts, 5 and 2, right? Great. This is also divided 3, and now we'll come here. This, sorry, I should have taken this. Okay, no problem. I'll take 1 and I'll take 6. Similarly, for this, we'll we'll simply say that, hey, divided into what is it? 387, right? 387, yeah. So we'll say that, hey, 3 8 will be one part, and the other part will be 7 and 9. 7 and 9. Great. Again, divided even further, divided even further. Now this will be 3, and this will be 8. Great. Uh, Let me copy paste it here. And if I say this is nothing but this is 9, it's gonna be 7. Great. Have we reached our base case? We have. We have, right? Because we have single sorted array. We have sorted array. This is sorted, this is sorted, this is sorted, this is sorted, right? These all are sorted. If I give you an array with length 1, right, you will obviously say that, hey, this is already sorted. So you don't need to sort it even further, right? This is already sorted. Great. So what you need to do is now somehow send this back, send this back, and this array that was there, you need to sort it. It should come like this. Go back, go back. This should be 2, 3, 5, right? This should be again, go back, go back. This should be 1 comma 6. Go back, go back. This should be 1, 2, 3, 1, 2, 3, 5, and 6, right? Similarly for this line, 3 comma, oh sorry, 3, 8, right? This is again 7 and 9, already sorted though, but yeah, already sorted. Then this goes back. This will sort it as 3, 7, 8, 9, and this will go back. How will it go back? 1, 2, 3, again 3, uh, 5, 6, 7, 8, 9, right? This is how the sorted array will look like. Am I right or am I not right? I think we are right for this thing, right? So every time, you know that a single element, a single element will always be sorted, right? If an array is given to you with length 1, right? With length 1, you will notice that it is always going to be sorted. Obviously, because there is no other element that you need to compare it with, right? So these two are sorted. This is sorted. This is sorted. But now when we go back, right? When we go back in our recursion tree, when we go back, we need to find a way somehow that this array becomes sorted. This array becomes sorted. We'll find that way when we'll write our code because it's a very simple thing. And there is a very famous question that merge two sorted arrays uh, with extra space. You mean you can probably search around, you can do that, or else we'll write the code so you don't need to worry about it. So this is the recursion tree, right? This is the recursion tree. And when it goes back, it will be sorted. We'll write the we'll write the logic, but I hope you understood, right? I hope you understood that when we divide it, we have done our part by dividing it till here. Now when we go back, then comes our play of conquer or slash merge, right? We are conquering something. We are achieving something out of it. We are just not dividing it and just going back without doing anything, right? We are merging it so that we, at the end of the day, we get a merged code. Great. For this, let me just copy this uh, array and paste it down here, right? I should paste it down here. We need simply, we need few parameters, right? Just to solve this whole array. Let me keep my laptop on charge. Hmm. Where is that? Yeah, already started. Great. So, to sort it, we need some parameters, right? We can keep our low pointer here and high pointer here. I don't think there is any problem till here. Great. So let's try to write our pseudo code, right? So pseudo code. What is the spelling mistake? Okay, yeah, this is the pseudo, right? Great. Let's use some other. Let's try to use blue. Okay. So let's say that hey, my name is going to be merge sort, right? And yeah, and this will take some parameter. Now, what is the parameter? Obviously, first will be the array that is given to the input array. It will take some low pointer and it will take some high pointer, right? Initially, our low pointer and high pointer will point to low as 0 and high will be n minus 1. That is for sure, right? Again, great. We'll write our base case here later on. We'll write it later on. But before that, let's do something, right? Let's, okay. Yeah, let's write some code. Okay. I'll say that, hey, first you need to find what is the mid. Okay. What is the mid? Mid is nothing but low plus high. Oh, I'm really sorry for the inconvenience. Yeah. Low plus high by 2. Now, what is low given? Low will be given as somewhat 0 and it will be given as n minus 1 initially. And what is n? N is 9. So 0, 0 plus 8, that is 8 by 2, that is 4. So 0, 1, 2, 3, 4. Till here, like I told you, right? You can obviously take, you can take till 0 to mid and mid plus 1 till high. Or you can say that case 0 to mid minus 1 and mid to high. You can see again. It's your preference. If you want to take the seal or you want to take the floor of the mid, right? Whatever you do, I am taking just the default value that is going to be the what is it going to be? It is going to be the floor value, right? The seal value. Sorry. So 0, 1, 2, 3, 4 till here, I will divide it, and then by this you can divide it further. Okay, it's your preference. You don't need to worry about this anywhere. So if I remove this, right, where were we? We were here, right? We were here. Now that I've calculated my mid, I'll say that hey, merge sort what? Again, I need to pass the array as it is. I pass the array. Now I'll say my low will remain the same, but my high will now be pointing to mid. Am I right? I told you that what is mid right? What is mid right now? Mid is nothing but low plus high divided by 2. So from low, here is my mid. Somewhere here is my mid. So I'll do one thing. I'll just take this part first and this part later on, right? I will divide it somewhere here. I will put a imaginary line here, and then I will sort this first and then I'll sort this. Understood? Great. So I have taken this. Now I'll say that, hey, you have already sorted the left part. Now you need to sort the right part also, right? You need to sort the right part as well. So I'll say that, hey, array, you should start your low pointer with mid plus one and you should go till high. No worries. Great. We have done that. Now, somehow I need to write my, okay, first till here, I am dividing my algorithm. I am sorry. Uh, we are doing the divide part first, and now let's conquer slash merge, right? If I scroll down a little, yeah, here, right? Now we need to conquer. Now we need to merge things. I'll say that, hey, just simply array my low, my mid, and my high. You just take all these things and give me the merge sorted array. Great. We have merged. We have merged everything. So assume, assume that this part is dividing and this part is conquering. This part is conquering. Great. Since this is going to be an in place algorithm, we don't need to return anything. We don't need to return anything. But we still need to write our base case, right? And by now, I hope, really sorry, I hope you already know what the base case is. Let's try to figure out what's the base case. Okay, let's take this example. What is my low pointer here? My low is going to be 0, 1, 2, 3, 4. My low is going to be 5, right? My high is also going to be 5 since everything is here only and my mid is also here only. But I won't calculate it obviously. But yeah, first I'll see that, hey, my low here is pointing to this position, my high is also pointing to this position only, right? So I'll say that uh, my base case is simply nothing but if my low is greater than or equal to high. Why am I taking greater than? It's just for safety concerns. You don't need to write greater than, but obviously you need to understand that if what if your code overflows, you need to have a base case that is safely written so that it doesn't even overflow. It doesn't even get overflowed, right? So I'll say that, hey, just return, just go back, just go back from this position, right? You were saying that, hey, just go back, just go back, just go back, just go back. You were sending it back, right? You were sending it back. So this is that base case. That, hey, just please go back. I don't want you to divide it or merge it further. I just want you to just go back and return whatever it is, whatever you have got. Return whatever you have. Great. So we have already merged things. We have already divided. Are we good to go with our logic? Let's do one thing. Let's try to implement it some. Let's try to dry run it. Okay, let's try to dry. I'll take this much. I'll just copy this. I'll paste it somewhere here so that you know what your array should look like. I'll just drag it down. Great. You now know that this is what your array is. So if I write array, array, n is nothing but 4, right? We need to take a simple example so that I can, at least tell you how recursion works, right? So n is 4, and so let's start here. What is our low? Low will be 0, and high will be at 3. 0, 1, 2, 3. Great. This is our low. This is our high initial, right? So I'll say that let me take some other example. Can we have a different stencil? Hmm. Great. If I take brown, how does it look? Fine. Doesn't matter. So 0 and high is 3. Is 0 greater than or equal to 3? You will say no. The base case hasn't been found yet. What is my mid right now? It is nothing but how do I stroke it? My strokes width is still greater. Okay. I'll do one thing. I'll just drag it somewhere. Fine. My mid is 0 plus 3 divided by 2. That is nothing but 1. That is nothing but 1. So I'll write 1 here. Great. So till now I'm saying that hey, merge sort here. This is what it is being called. And what is my array? Array is already given to you. This is your array. And what is your low? Low is still again going to be 0. And what is your high? It is going to be till mid. And what was your mid? Mid was 1. Great. So 0, 1. Great. 0, 1, 1, 3. Great. Is 0 greater than or equal to 1? No. Again, you will find the mid. What is 0 plus 1 divided by 2? It is nothing but 0. Right? You will again take this. You will take this. Great. What is my array? Array is already given. What is my low? Low is 0. High is 0. Is my base case found? Yes, it is found. It will go back. It will go back. Great. I think I have done this part, so we'll write it here somewhere. Let me paste it. Let me say that here it is telling you to do your base case. Great. So now my base case mid was found at 0. So what is mid plus 1? It is going to be 1. And what is my high? High is nothing but 1, right? High is 1. And my mid plus 1 is going to be 1. Is 1 equal to greater? Is 1 greater than or equal to 1? Yes, it is. You just return. Great. You just return. No problem. Is this done? Yes, this part is done. So this will go back to this part. Now this comes. Now this part comes. We'll just write it here, right? We'll just write it here. Now what is my low? Sorry, my low will be mid plus 1. What is my mid? Mid is 1, so 2. And what is my high? 3. That is given here. Great. Is 2 greater than or equal to 3? No. You will again find out what is mid. Mid is 2 plus 3, that is 5. 5 divided by 2, that is 2, right? What is my merge sort then? This will look like something like that. Great. So, uh, obviously, when you are dividing here, when you have already sorted these things, you need to obviously now merge con do these merge part, and obviously, and assuming that all these are merged, right? Assuming that this part, so when we were at this position, right? When this went back, I am assuming that merged part has already been executed and it is already merged. It has sent back what is the merge sort. This has already sorted the left part, and now we are sorting the right part. So I hope you obviously are with me and you know that we are already obviously in this part you won't get till merge. This part also you won't get till merge. But when these two things are already sorted, then you will when these two parts have already been executed, now this line will come. And when this line comes, then you will return back, right? Then you will only return back. And I hope you understand that I have already merged. We'll write that code. We'll write that code later. So you don't need to worry about it. It's very simple code, right? So high is 2. Sorry, mid is 2. Now I am saying that low is going to be, what is low? Low is going to be 2. And mid is, and what is my high? High is still mid. And what is my mid? Mid is 2. Is 2 greater than equal to 2? Yes, just a little. Now this line execute. Great. If this line execute, what is my uh, what is my mid plus 1? Mid was 2, so mid plus 1 is 3. And what is my high? High is also 3. Is Will this base case run? Yes, it will run. Go back. When you go back, these two lines are done. So basically you've already divided things. And now you need to merge. You merge. You just merge your array. You just merge your array, and I hope you understand that we have somehow this. Let's just assume that it has already run. So we just go back here. We just return. We just return. Sorry, we just return. When we return here, so this position is already done. And when this part runs, this will somehow give you one. What is the array given you? 1, 2, 3, 5. Is this what we required? Where is it? Is this what we required? So if I just zoom out a little, is this what we required? So 5, 2, 3, 1 was our initial array, and this is our sorted array. This is our sorted array, right? This is what we require? Yes, this is what we require. Great, great. Now let's simply write how our merge code will look. Merge code, right? Where we are passing array, we are passing the low, we are passing the mid, we are also passing the high, right? And let's write. Simply do nothing. Do nothing. Just take, you just need to. So when you are here, right, you just need to have a simple, a temporary array, right? A temporary array. Great. Now, what is your temporary array? Temporary array is nothing, but it is going to be the array which will replicate which will contain the sorted elements, and then you will finally push all those sorted elements back to your array, right? So we are taking a temporary array. Great. I'll say that hey, we need a, a left pointer which will be pointing to somewhere here. Okay. Let's assume that we in this situation. So if I write the recursion tree, where are we? We had to write 4 comma what was it? 4 comma uh, this one, right? I need to copy it. So I'll just delete it and just copy it. Great. If we write a recursion tree, it will look something like this: 5 comma 2, 3 comma 1, and this will something look like 5, 2, and this will look like 3. This will look like 1. Great. I'll do one thing. I'll just assuming that I am given 5 and I am given 2. At the end of the day, these both are part of the same array, although we are dividing it, but we are not settling it into some other array. Have we? This is what our merge sort code looks like. Are we setting it? Are we setting any of this into any other array? No. So basically, we are just hypothetically dividing it. We are just hypothetically dividing it. We are just mentioning that hey, this is a mid, and this will be somewhere. So low will be pointing my here, and my high is also here at this point of time. So low is here, high is also at this point of time. So I'll say that hey, and what is my mid? Assuming obviously when you are at a base case, you won't find the mid. But hypothetically, if you have what is my mid? Mid is somewhere here, right? The mid is also somewhere here only, right? If you what is L in H? L in H is 0, 0, and 0 plus 0 divided by 2 is going to give you 0 only. So here is only your mid. I'll say that hey, put my left pointer here and put my right pointer at mid plus 1. Anything that is greater than 1, sorry, greater than mid. So 1 plus mid, right? I'll put my mid pointer here. Now I have a temporary array. I have a temporary array. I somehow need to push these values when I'm going back. I need to push these values to this array somehow that it should look like 2 comma 5, or maybe you can say that it should look like a sorted array. It should look like a sorted array. Now how can I do it? If my left pointer is here and my right pointer is here, I will compare that hey, is my array of left greater than array of right? You will say no. Then do nothing, just put my right pointer in the temporary array, push my right pointer here and push my right pointer to plus plus. So basically, you just increment it. Now my R pointer is somewhere here, which is out of bound. It is out of bound. Since it's not it's not a part of your array. It's since your array is given as what? It is of length 1, and when you push your r, when you increment your r, it goes out of bound. And then what you'll say that, hey, push everything that is there in my right. I'm assuming that my right part has already, sorry, my left part. Push everything that is there in my left part, and I'm assuming everything here is sorted, right? I'm assuming that everything is sorted. Just push everything that is there, L, and just push L plus plus, increment it. Is it out of bound? Yeah, it is out of bound. Simply just go back. Is this what we require? Is this what we require? Yes, great. So I'll say I am going to put my right pointer at somewhere mid plus one. Great. Now I'll say that, hey, while my left pointer is lesser than mid and lesser than and equal to and my right pointer is less than my uh, equal to high. I will simply just say that, hey, if my array of left is uh, greater than array of my right, um, temp dot push um, array of, or maybe you can say that, hey, if my left pointer is lesser, if my left pointer is lesser, then push array of left plus plus. I'm just incrementing in the same line. Else temp dot push array of, where is it? Right plus plus, right? This is what I've already done. If if still if still my left pointer is somewhere and my left part has already are there are some elements that are still left in my left part, you just do one thing, that, hey, left part is, if while my left part is lesser than equal to mid, I will simply return, sorry, I will simply just temp dot push my right plus plus, sorry, my array of left plus plus. And if there are some elements that are still left, if there are elements that are still left in my right part, then I'll say that, hey, just simply say till high, or just simply say that temp push array of right plus plus. Great. Now I will assume that my temporary array contains the sorted elements. Now it contains the sorted elements of the array. Now you need to push back something in your right, in your array, right? You need to, basically this is an in place thing. So basically you need to modify your original array only. So you will push all the sorted elements in your array. I'll say that, hey, let's run a loop which will start from low and go with till equal to high and I plus plus. My array of I will look like, sorry, my array of I will, yeah, correct, will look like temporary of I minus low. Now, why have I written this? Great. Let's assume things. So where were we? Which example should we take? Okay. So basically, this example is what we should take. Is this example what we should take? Um, this is 5, this is 2. Where is my low at this position of time? My low is at my low is what? Low is 0. My mid is also going to be when we divide, where is the recursion tree? We written it for it. No. Okay. So low, mid, mid plus 1. Mid is going to be 1 then. And here when I divide it even further, low is going to be 0. Okay. So what is our mid going to be? Mid is going to be what? It is going to. So high is also going to be 0. Obviously, my high is also going to be 0. So and mid is going to be 1, right? Sorry, mid is also going to be 0. And when you will say that here left is 0, right is 0, right is mid plus 1, so right will become 1. And you have pushed everything, so this will something look like 5, comma 2, where low is here, and I should look like here. I'm not sure, but yeah, here, right? So array of I, what is my array of I? Array of I will start from 0, and it will go till 0 only. What is my I? I is low minus, what is I? I is nothing but 0. So 0 minus 0. What is at my 0 minus 0 position? It is 5. This is my 0, this is my 1. So what is here? This is going to be, oh sorry, this had to be 2 comma 5, 0, 1. This obviously temp will look like something like 2 comma 5, right? It is sorted already. So what is at 0 position? It is nothing but 2. So array, so at array of I position, my 2 will encounter, my 2 will go inside, my 2 will go inside. So for this, at this position, 2 will go inside. This will look like 2 comma 5. This will look like 1 comma 3 when this comes up. And when this merge sort is, and when your merge will be called, then my 1, will be pushed at the first position. So array of I will look something like um, um, basically my temporary of what do you call this? I minus low, right? And my low will be somewhere here. I'm not sure. You need to track your basically you need to write your recursion tree, and then you will find out why I have written I minus low, right? So this is done, and then simply you have created your merge code as well. Merge code as well. Great. Let's try to implement it here. I'll say that merge sort. Do I need to return anything? Given an array, sort the array and return it. Okay. Uh, I'll pass my nums. I will pass my low pointer. I will pass my high pointer as nums dot length minus one. Great. We have already sorted and we need to just return the num. Let's write our merge sort. It will take an array. It will take a low pointer. It will take a high pointer. Great. Now let's write our base case. Now that we already know what our base case is, if my low is greater than equal to high, just simply return. Great. Now divide, right? So merge sort, I'll just pass my array, I'll pass my low, let's first calculate the mid. Let mid is equals to low plus high. Divide by 2. Great. Let's pass till mid. And when we have sorted our left part, let's sort our right part as well. Let's say that, hey, mid plus 1, it should start from mid plus 1 and go till high. Now conquer slash merge. Great. Let's write merge what? Array, low, mid, and high. We have passed it. Now let's write the merge function. It will take a it will take an array, it will take low, it will take mid, it will take high. Let's write the code. Great. What was our code? It looks like this. We need to initialize a temporary array first. So let temp is nothing but a temporary array. Let left is equals to 0, or maybe it can start from low, or should it not start from low? Maybe we can start it with low. Doesn't matter. We'll check that later. And right will be nothing but mid plus 1. Great. So while my low, my left is less than equal to mid and my right is less than equal to high, I'll say that if my array of left is less than array of right, just push my array of um, left plus plus, else temp dot push array right plus plus, right? Now we'll check if there are still element left in my left part. I'll say that while my left is less than mid, less than equal to mid, uh, temp dot push array of left plus plus, and simply we'll if elements are still left in my right part while right is less than equal to high, I'll say temp dot push array of right plus plus. Great. Assuming temp array contains sorted element. Now let's push everything back into array so that it also looks sorted. So we'll start our loop. We'll start from I is equals to low. We'll go till what is happening. Okay, I plus plus. I'll say my array of I should look like temporary of I minus low, right? And do nothing because it is already sorted. Let's try to run this and see if it passes or it fails. Great, it failed. Wow. So let's do one thing. Let's start from low then. Okay, undefined, undefined, undefined. What is the problem that we are making? I am taking my mid. I am passing my low to mid. I am passing my mid plus one to high. Great. Let's try to debug it. For people who already understood what was the problem, this was the problem. Wow. So I'm really sorry, guys. I really forgot that hey, my JavaScript is it takes dynamic variables, right? So it does not have any uh, type of the variable, right? So we need to take the floor value here. We need to explicitly define that hey, when when my array's length is odd, right? When my array's length is odd, it will look something like 4.5. Let's just say the length is 9. So it will divide it by 2. Really sorry. And it will say that hey, the length is now 4. It is now mid looks like 4.5. And my mid will hold that 4.5 only. It will not hold the floor value or the seal value. It will hold that decimal, that floating point. So you need to explicitly define that hey, just take the mid, the floor value of it. And simply you will see that if I again try to run it in front of you, my array, my cases are already accepted. Let's try to submit it. Uh, yeah, great. It is submitted. It is accepted. Great. So let's quickly understand what's the time complexity and what is the space complexity. For that, you need to understand this. Sorry, you need to understand this algorithm, right? I am dividing everything by 2. So if this is n, I will divide it by n by 2 part here, right? Then this is n by 4, this is n by 4, this is also n by 4, n by 4. This looks like n by 8, n by 8. This also n by 8, n by 8, and so on, right? If I take any example, if I take any n, I am always dividing it by 2. I am further dividing it by 2, dot, 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 till when? Till when the length n looks like, sorry, not L, n, m looks like, what? N looks like 1. Till my m looks like 1, and this is nothing but m only, right? If my m is 1, then I am going back, right? That is what our base case looks like. So if I zoom it a little, this is what our base case is. Low is greater than equal to high, which is nothing but when low and high are pointing at the same position, 0, comma 0 or 1, comma 1, whatever you want to take, right? So I am dividing everything by 2. And you will notice, right? You will notice, see, this is length n. This is length n. Sorry, 9, right? 9 divided by 2, 3. Or I mean, or 3 only, right? This again, 3 divided by 2, it will take 1. This 1 divided by, where is it? Sorry, where is 9? 9 divided by 2 is 4, and this will be 3. 4 divided by, 4 divided by 2 is 2, then 2 divided by 2 is 1, right? How many cases, how many, what is the depth of it? So depth of it is nothing but 3. And what is 3 square? It is nothing but 9, which is the length. And what is 3 looks like? It is nothing but log base 2. 9 is nothing but 3. I hope you understand that we are, every time we divide, we are dividing it um, by 2, right? So basically, my time complexity for merge sort looks like logarithmic base 2, comma, log base 2 of n, right? Log base 2 of n. Great. Now comes this merge sort, this merge part, right? Where is the code written? Let's kind of go there. Let's kind of go there. Great. So, sorry, this should not be 0. It should start from low, right? It should start from low. This is not 0, right? Okay. So this temporary array, this is, we'll discuss what's the space complexity. This is O of 1. This is running in O of n. Almost, I'm saying almost. Again, O of n. Again, O of n. Right? O of 3n. Not exactly O of 3n, but the worst case that I'm figuring out is O of 3n. Right? The worst case. So I can say that, hey, n into log n. This is what our time complexity will look like. Great. What is my space complexity? I am taking one extra space for this array, basically this temporary array. Obviously, the space will vary every time in the recursion tree. Every time it will be either, sometimes it will be of length 2, sometimes it will be going to be 3. But on the top case, when we'll be here, and the first part that is going to be merged, the first recursion branch, these two branches, when these go back and when they merge, it will something look like 4 places, 0, 1, 2, and 3, 4 places. So we can assume that we are taking an extra space of O of n, right? This is what our entire time complexity and space complexity looks like. Great. Now that we have solved this sort and array question, right? Then we'll move forward with what was the question? Inversion of array. I will just quickly, is it on Coding Ninjas? Okay, no problem. I don't think it is on Leetcode. I'll try to search for it. I'll try to search for it if it is there. But yeah, I'll make a separate video of it and just assume that merge sort will be entirely be called inside this function. inside this function. So you need to know how merge sort works. Thank you so much for joining in. I'll try to upload this video, and after this video, I'll try to shoot for this inversion of array. Right. Thank you so much for joining in. I'll see you tomorrow. I'll see you in the next video, maybe in the next video for inversion of array. Thank you. Goodbye.